Start with one person. One person who knows a rumor, or carries a virus, or shares a video. They tell two people. Those two each tell two more. Nothing alarming, a handful of people, a quiet little ripple. Round by round it doubles. 1, 2, 4, 8, 16, 32. It still feels small. It still feels slow. That feeling is the trap. Because 30 rounds of doubling does not give you a big number. It gives you over a billion. From a single person, in 30 steps. The reason it ambushes us every single time is a simple gap in our heads. We feel growth as adding a little at each step plus one, when what's really happening underneath is multiplying. That hidden engine has a name, exponential growth. And once you see how it really moves, the world looks different. Let's make the doubling precise. Start at 1 and double every round. After n rounds, the count is 2 to the power n. That little exponent is where all the violence hides. 10 rounds in, 2 to the 10th, you're at 1,024. About 1,000. Still nothing, a packed lecture hall. 10 more rounds, 2 to the 20th, and you're past 1,000,000. The same 10 doublings that took you from 1 to 1,000 now added 1,000,000. 10 more after that, 2 to the 30th, over 1,000,000,000. Each block of 10 rounds doesn't add to the last. It dwarfs everything that came before. By round 33, you have passed the entire human population, every person alive, from a single starting case, in 33 doublings. Sit with that jump. Going from 30 rounds to just 33, only 3 more steps, added more than 7 billion. The end always comes faster than the start suggests. Here's why it fools us. Our intuition is built for linear growth, adding the same amount each step. One brick, then another, then another. A steady, predictable climb. But exponential growth multiplies each step instead of adding. Times 2, times 2, times 2. And multiplying, repeated, behaves nothing like adding. Put them side by side. The straight line crawls upward at a constant slope. The exponential curve starts below it, looking lazy, and then tears straight past it and keeps going. That's the shape of every exponential. Flat, flat, still flat, and then a near vertical wall. And the curve looks the same at every zoom level. There's no point where it settles down. The deepest trap is this. Looking slow is not the same as being slow. By the time an exponential looks dramatic, almost all of the action is already behind you. There's an old legend that captures this perfectly. An inventor shows a king a new game, chess. Delighted, the king offers any reward. The inventor asks for something humble, just a little rice, counted on the board itself. 1 grain on the first square, 2 on the second, 4 on the third. Just double the grains on each square, all the way to 64. The king laughs and agrees. It sounds like a bag of rice. And through the first half of the board, it stays modest. By square 32 you're at about 4 billion grains, a lot, sure, but a few truckloads. Still something you can picture. Then the second half detonates. The 64th square alone demands 2 to the 63rd grains, more than 9 quintillion. A number with 19 digits on one square. Add up the whole board and you get around 18 quintillion grains, more rice than humanity has grown in all of history. The king, of course, could never pay. That's why people say the danger is in the second half of the chessboard. The early squares lull you. The late ones break the world. Exponential growth saves its real power for the end. For something spreading between people, one dial controls everything. Call it R, the reproduction number, the average number of new cases each case creates. If R is greater than 1, each case more than replaces itself. The numbers double and redouble. That's the explosion, the curve we just watched. If R equals exactly 1, each case replaces itself and no more. The outbreak holds steady. If R drops below 1, each generation is smaller than the last, and it quietly dies out. So the entire fate of an epidemic balances on a knife edge at exactly 1. Just above, catastrophe. Just below, it fades. A tiny difference, opposite outcomes. And this is the hopeful part. Vaccines, masks, distance, washing hands, Every intervention is doing one single job, dragging or below that line of 1. You don't need to stop the virus from spreading entirely. Push her from 2 down to 9/10, and the very same virus turns from an explosion into a fizzle. When something is growing exponentially, forget the current number for a second and ask one better question. How long does it take to double? There's a wonderfully simple shortcut, the rule of 70. Take the growth rate as a percentage, divide it into 70, and that's roughly the doubling time. Money growing at 7% a year? 70 over 7, it doubles in about 10 years. A population, an investment, a subscriber count, same rule, same arithmetic. A virus doubling every 3 days is just the identical math on a faster clock. 10 doublings in a month means a 1,000-fold increase, which is how a handful of cases becomes a wave. And notice how sensitive it is. 2% growth doubles in 35 years, 7% doubles in 10. A small change in the rate is an enormous change in how fast it all comes at you. Let me show you how violent doubling really is. Take an ordinary sheet of paper, 1/10 of a millimeter thick, and imagine folding it in half, again and again. Each fold doubles the thickness. You'd think you'd get a thick wad. But 42 folds, just 42, would stack up past the moon, 400,000 kilometers away. From one sheet of paper. Now a gentler version. A lily pad on a pond doubles the area it covers every single day. On day 30, it covers the whole pond and the fish suffocate. So here's the question that catches everyone. On which day was the pond only half covered? Not day 15. Day 29. The day before the end, half the pond still looks clear and fine. That is the real menace of exponential growth. It hides in plain sight, looking harmless and manageable, right up until the one step where it's suddenly everywhere. But here's the honest other half of the story. Nothing actually grows exponentially forever. If it did, a single bacterium would become a ball of life heavier than the planet within days. Real growth runs out of room. The virus runs low on people left to infect. The product runs out of new customers. The lily pad runs out of pond. Each round has fewer fresh targets than the last. So the curve that shot upward eventually bends back over and flattens into a lazy plateau. That S-shape, explode, then saturate, is called the logistic curve, and it's how growth really behaves in a finite world. Which means every exponential you'll ever meet is really just the early chapter of an S. The explosion is real, but so is the ceiling waiting at the top. Once you have this lens, you start seeing the same curve everywhere. Money compounding in an index fund follows it. A virus moving through a population follows it. A video spreading share by share, a chip's transistor count under Moore's law, a growing population, all the same underlying math, wearing different costumes. And there's a single tell that marks every one of them. Whenever a thing grows by a percentage of its own current size, it is exponential. That's the signature. A wildfire and a savings account feel like opposites. But draw their growth, and it's the identical curve, one you'd run from, one you'd lean into. So take one habit from all of this. When something is growing, don't be reassured by how small it is today. Look at the rate. A tiny number that doubles will bury a huge number that merely adds. The doubling is the whole story, and it cuts both ways. It's the thing to fear in a virus or a debt, and the thing to harness in your savings or your skills. Your gut will keep insisting the world is linear. It isn't. And now, when you see a small thing quietly doubling, you'll know exactly where it's headed, because the curve always wins.